go ahead and we put it to use. So let's talk about working with data. So data formatting, when data comes at you in the real world, it's going to come back at you in a bunch of different shapes and sizes and quantities. It'll come nicely packaged, and generally comes in a way that you really don't like it. What this means is that you have to know how to manipulate it and transform it into a format that you and your program can deal with. Python has all the tools that you need. Now the question is do you know how to use those tools to transform data into something that you can use? Excellent question. So let's give you a programming challenge. Good news, you may not have known it, but Polytechnic has a track team. He does now. Go platypus. The coach really wants the team to win the state competition in its first year. That'd be good for the coach, it'd be good for the school. Okay, he's been recording their training results from the 600-meter run. Now he wants to know the top 3 fastest times for each team member. Some people in this class would say, great, let me take a look at the times and I'll figure out what they are. No! Don't do that. We'll write a program to do this. So let's take a look at those times. Hey look, so we've got 4 runners, James, Julie, Mike, and Sarah, and we've got a bunch of times for each one of them. What does the coach want?
Top 3.
Top 3 for each person, right? So we should be able to write a program to do this. How hard can that possibly be? It can't be that hard. All right, let's do it. Okay, step 1, what do we have to do? Well, we have to get the data. Okay? So let's begin by reading the data from each of the files into its own list. Okay, so we have their data in their own special separate file. Great. We're going to write a short program to process each file, creating a list. We like lists. Lists are our friends. For each athlete's data, and then we're going to display the list on the screen. Try splitting the data on the commas, and don't forget to strip out any unwanted white space. This cannot possibly be all that hard to do, can it? Hey look, it's Python code!
Wow. That really fast.
Alright, here we go. So James data, open, James text, and an R. Why do we put an R? Read, that's right. Data equals James data, read line. And God's honest truth, all this stuff is on a single line, so we sucked in all the data out of the file. Julie data, Mike data, Sarah data, print James. Remember, James is the one line of data we sucked in. James, Julie, Mike, and Sarah. So what should we see? It's like one line of text from the file, right? So you'll be, oh wait, no. I apologize, I skipped over something a little subtle here. It's this line here, we got some action going on. Okay, so what do we got going on here? James equals data dot strip dot split, and then a comma. Huh. What's going on there, do you think?
Takes a chunk of data and splits it up.
Yes. Well, what's interesting on this is you read it right to left. So the very first thing we're going to do is we're going to split it based on commas. What does that actually mean? So we're starting with a string, right? We're going to split it based on commas. Okay, that's cool. So it sounds like we divide up the number, the values that are coming in, separating by commas. What do you think that's going to produce? A bunch of values, right? What do you think we'll store those values in? I'm sorry, did you say array?
Yeah, I'm still
Stop that! Wrong language!
Yeah.
So it's not an array in Python, what is it?
List.
It's a list. Alright, so we're going to assume it sticks in a list. Then we got strip, paren. What do you think strip, paren is going to do? Any blanks around any of those numbers we're going to get rid of, right? Alright. Let's give it a try. Is that pretty much what we were expecting to happen?
Yes.
what did we get to come out here? Okay, so I see a square bracket. I see a square bracket. So generally that means that we're dealing with a list, right? 2-34, little quotes, run a comma, 321, all that sort of stuff like that. So it looks like it's a list of strings, right? Are there any spaces or weird stuff going on there? No. Fantastic. Okay, we're done, right?
Maybe. No, we ain't. We have to get the lowest scores for each of those guys. Come on now, Dr. Anderson. You can do it.
I was ready to be done.
You can do that.
So a couple new Python ideas for you. We sort of slid them past you, so if you're not careful, you might not notice them when they show up. Data strip split. So it's called a method chaining. Oh, hey. Chain your methods together. Make sure they don't run off on you. The first method, strip, is going to apply to the line of the data which removes away all unwanted white space. And I apologize. I think I got this wrong. So this is the first one applied, and that's the second one. I got functions going the other way. So we get rid of all the white space first. Okay? And then the results of the stripping process by the second method, split, chop, chop, chop. It's going to separate everything based on where the commas are, and it's going to create a list, which is cool because that's what we're talking about with this. The resulting list is then saved in the variable. This way the methods are chained together to produce a single required result. And you have to read it from left to right. And that's the variable that we're doing all the stuff on. Question?
Relation to your data values have colons. It's not colons, it's not dashes, it's not periods.
Yes. Because the coach did a poor job of answering these. Okay. Okay, so now it's time to do some sorting. You like sorting, right? Because you're the king and queen of bubble sorts, right? Okay, now in Python, there's two different types of sorting. There's something called in-place sorting, which takes your data and then changes your data, which means your old data gone, and it replaces it with a sorted version. That actually sounds sort of funny. Replaces your data with a sorted version of your data. Okay? There's another thing called copy sorting, where you take your original data, you make a copy of it, and then you sort it. So your original data is still there, and is still in the original order that it was. You didn't modify it at all. Okay? Two different ways to go. The sort does this. Sorted, in the past tense, does this. So sorted means that you're making a change on it. Sort is actually changing the actual variable itself, and the old unsorted version is now gone. Okay? So we got another version of the code. All right, now we've got a brand new version of our code. All of this boring stuff is exactly the same, but look down here, we have print sorted James, print sorted Julie, sorted Mike, and sorted Sarah. So what's this going to do to our little running time values? Cool. So then we should be good to go, right? Okay, let's do this. Woohoo! Are we done? We sorted it, right? So
Yeah, no, it's not.
No, you gotta get the first three. You gotta take them out.
Yeah,
You gotta cut them.
data is,
Paste them.
it's
222, 234, 234, 245, 201.
Somebody done that stuff there.
Come before periods, which come before colons, so they all use the same.
I don't know what happened there.
So what's going on here? What's my problem?
You're separating characters, so it's hyphens, periods, and colons have a different hierarchy in this order.
Hierarchy.
I couldn't think of a better word for it.
It's a good word.
think so?
No.
I think I can. So let's take a look at what's going on here. So we're having problems. We've got dash, period, and colon. And as we've been attempting to use a fancy vocabulary to say, they all have a different ASCII value, right? So let's take a look at our fantastic handy-dandy ASCII chart. Let's see. Semicolon is a 45. Oh wait, I'm sorry. Dash is a 45. Period is a 46. Go all the way down here to 58, and that's where a colon is. So when we're doing our sorting, it's using these number values to figure out what goes in what sequence. Well, to coach you to enter the data correctly in the first place, we wouldn't be having a problem, right? But we got dirty data, right? Gee. All right, so that means to screw up our data. So Sarah's data, which is 2:58, 2.58, 2:39, 2-25, it's all garbly googly goo.
So set them all to the same value.
You like that a place?
We need to do something, right? We gotta somehow change these all into what they need to be. Non-uniformity is causing us to be. All right. So let's create a function called sanitize. Dun, dun, which will take as input a string from each one of the athletes' list, and the function is then going to process the string to replace any of the bad characters with the good character. I mean, it sounds pretty good, right? And then it's going to return the good-looking string. If the string already contains a period, then there's no need to sanitize it, right? So we're gonna standardize on a period. We can standardize on colons or dashes, but we've decided periods are where it's at. So let's give that a shot. Ooh. All right, so let's see what we got going on here. Oh, hey, look! It's a function.
Nope.
And having graded some of your homework number 3, this may be a little bit of a surprise to some of you. It's a function, okay? How do we know it's a function? Def, sanitize, and then an incoming variable. Fantastic. So time string comes in. If dash in time string, okay, so we found a dash in there. Splitter equals dash. Else, elf, colon in time string, then splitter equals colon. Else, return time string. Oh. So basically, if time string has a period, we're back. We got a problem. Okay, assuming that we found something bad in it, minutes and seconds equals time string dot split based on splitter. So what we're going to do is we're going to find like 2-34. Turns out it's got a dash in it. We're going to split that into 2 and 34. We're going to place these two different variables because that's what we get back from the splitter. And then we're going to return, here it comes, minutes plus dot plus seconds. So we're basically building what we want to have returned. Okay, that sounds pretty good. Now we've seen all this stuff before. We open it up, we pull the first thing out, we're stripping and splitting and all that sort of stuff like that. Let's see what we're doing down here towards the end. Oh, it's getting complicated down here, is it? To create 4 initially empty lists to hold the sanitized runtime. Clean James, clean Julie, clean Mike, clean Sarah. Process each runner's time to clean them up. For runtime in James, clean James dot append sanitize runtime. All right, what's going on here? So we know sanitize. Well, what is runtime? So we're reaching into James and we're pulling out one of his runtimes. We're going to stick it in runtime. Then we're going to call sanitize with that runtime, and what's going to come back from that is a good-looking runtime value. 2.34, 2.01, 2. Whatever. Then we're going to append it to this brand new list called Clean James. That's cool. Then we do all that, then we come down to print, sorted, Clean James, Clean Julie, Clean Mike, Clean Sarah. All right, let's give it a shot. Woohoo! What do we got going on now? 2.01, 2.01, 2.22, 2.34, 2.34, 2.45, 3.01, 3.10, 3.31, 3.21. Did we sort it correctly? Success! Thank God, we're done now.
But wait, there's no. Oh, there's more.
Woohoo! So we create 4 lists to hold the data, it's right from the data files. Then we create another 4 lists to hold the sanitized data. And of course, we're stepping through all the lists. There has to be a better way to do this. Well, we got 8 lists going around, right? We got 4 and 4. And then we're going through each one of the lists, actually a couple times, pulling all the stuff out and doing stuff with it. So, good news, we're doing a good job. It just seems like it's sort of a lot of code. Hey, transforming lists! A Python function that you do not yet know about. So transforming lists is so common, it's done so often. Python has a tool that makes it easy to do this stuff. The tool goes by the rather unwieldy name of list comprehension. List comprehensions are designed to reduce the amount of code that you need to write when transforming one list into another, which is really cool because that's exactly what we're doing right now, right? We're trying to take one list and the garbled one that we get from the coach and transform it into exactly the list that we want. So how does this work? Consider what you have to do when you're transforming one list into another. 4 things have to be done. What's the first one? Create a new list to hold the transformed data. I iterate across each data in the first list. With each iteration, perform the transformation, and then append the transformed data to the new list. So we created our clean James. We went over each item in the old James list. We would take a look at each item that we were looking at, and we would turn it, if it had a dash or a colon, we'd change everything to a period. And then we would find, once we had that cleaned up version, we would actually stick it on the end of our brand new clean James list. So here we go, look, clean Sarah is an empty list, 1. For runtime in Sarah, 2. Clean Sarah, append, sanitize runtime. So the sanitized runtime is 3, and appending is 4. 4 different functions we're doing to get this transform list thing taken care of. There must be an easier way to do this. Good news, Rich! So here's the same functionality as the list comprehension, which involves creating a new list by specifying the transformation that's about to be applied. So here you go, you ready? Mind-blowing stuff. Boop, boop. Okay, so here's clean Sarah equals sanitize runtime for runtime in Sarah. Okay, there's a lot going on there. Let's see what's going on here. Okay, so clean Sarah is going to be the list that's going to hold our cleaned up set of running values. The way we're going to do it is we're going to use this function, sanitize runtime, and we're going to get runtime from Sarah, which is the list that holds all the garbage values right now. This is the transformation, this is the data item, and this is the existing list that we're going to be pulling stuff out of. Does this seem to make sense? Yes. So we've reduced our transformation to a single line of code. And there's no need to specify the whole append thing because we got that taken care of. Well, let's take a look and see what this looks like. You remember last time we had a lot of code. So we still have our sanitize function. Remember sanitize, right? Now we have our open up the file and read in one line of data. And we strip it and split it. So now we have all of our individual values. Now look at this. All that complicated code where we have the new list, it's all been reduced to one line. Print, sorted, sanitize, runtime for time in James. So James contains the values as we read them from the file. Time is a single time value that we pulled out of that. Now we're going to go ahead and sanitize time, which means that if it doesn't have a 2.6, we're going to turn it into 2.6. And then we're going to sort it, and then we're going to print it. Single line doing an awful lot of work there. Let's see if it works. Or does it just break in half because we asked it to do too much? Woohoo! Question is, this should look like this, right? Does it? 201, 201, 222, 234, 234, 245, 301, 310, and 321. I would say yes. We've produced exactly the same output, but now we're only using 4 lines of text. Question?
So the difference with doing the one-line method is just it's a new way to apply a function to whatever new variable.
Right, using this transformation technique that we just talked about. So it's much more compact code, right? And it's not, and it is actually still readable, which is good. And the reason that we can do this is because in Python they realize transforming one list into another list is something that's done all the time, right? So they built in support in the language for it. Oh, fantastic. We're done! We've written a program that reads the coach's data from his data files, stores his raw data into a list, sanitizes the data, sorts it, and displays the coach's data on the screen, all in less than 25 lines of code. How cool is that? Because we're that good. We can go ahead and show it to our coach now and say, look, coach, we did exactly what you asked us to do, right? Right?
You were never on Teams then?
Well, actually, no. Because coach didn't actually ask us to do any of that, did he? What did he ask us to
Done
do?
the top 3, so then you just
He didn't want top 3.
no.
Alright. Producing the 3 fastest times for each athlete is what he wants. And oh, no dudes. You know, just chopping off the top 3 values would not be all that hard. Except it's that duplicate stuff that's going to kill us, right?
Yeah.
I mean, we could just print out Sarah 0, Sarah 1, and Sarah 2, which would be cool because it would be her 3 top values. Or we could do something called list slice, which suspiciously a lot of people in this class have already been using, although I'm not quite sure if you know what I'm doing. But list slice says Sarah 0, 3, which gives us the first 3 items, 0, 1, and 2, up to but not including 3. Okay? Either one of those techniques would work perfectly, and it would return the first 3 values in the list. But we have a little problem. What is our little problem? Duplicate values, right? This coach said he wanted the fastest 3 values. All right, so what are we going to do about this? So we do have a duplicate problem. So here's James's data, and you can see very clearly we've got duplicates in there. Okay? So processing a list to remove duplicates is one place where list comprehension isn't going to do any good for us. Our fancy new technique, not going to help one bit. Okay? Duplicate removal filter is basically what we need. And to remove this requirement, you're going to have to revert to the regular list iteration code. We'll go through that. Taking a step backwards is what we're doing here. Alright, so let's see what we got going on here. So we recognize this because this was our big fancy statement from last time, right? Sorted, sanitized, forward time, and James. Great. This gave us our list. It was beautiful, and it was wonderful, and it was sorted. Now we have to process each one of the runtimes and eliminate any duplicate. Unique James, unique Julie, unique Mike, unique Sarah. For runtime in James sorted. If runtime not in unique James not append runtime. That make sense? So we're going to go stepping through each one of James's running times, and we're going to grab one of them. And we're going to say, hey, is this time value currently in our brand new list? If it's not in there, stick it in there. And then we'll go grab the next one and check to see. And this should hopefully allow us to avoid any duplicates going on. Okay? And then we go down here. Oh, wait. Go right here. Print unique James, square bracket, 0:3, square bracket. So this should print out 0, 1, 2. So basically the top 3 values. Let's give it a shot and see if it works. No duplicates allowed. Woohoo! 201, 222, 234. So those are his fastest times. Are there any duplicates there? None whatsoever. And really no duplicates anywhere. 211, 223, no. We seem to be doing, woo! We've done it, right? And this is what the coach asked for. Didn't he ask for the top 3 times? Pretty cool. We're using our mad Python skills to make this happen. we did that using lists, but that's just one way to do it. Another way to do this might be to use like sets. And what's the power of sets? They don't have duplicates, right? Can they accept duplicates? Can I throw multiple copies of the same thing into a set? What happens when I do that? It says thank you, and then just put it in there, right? Because it's already there, right? Huh. Okay, so they're unordered as duplicates aren't allowed. You try to add data items to a site that already contains the data items. Python simply ignores it. Okay, we're cool with that. It's also possible to create and populate a set in one step. You can provide a list of data values between the curly braces or specify an existing list as an argument to the set. Distances equals 10.6, 11, 8, 10.6, and 2, and 7. Duplicates will be ignored. So if I was creating a set like this, I'd only get one version of 10.6 in there. Any duplicates in the James list will be ignored. Distances, which is a set, equals set James. So one simple statement, all James's duplicates go away, right? Wow, this seems like it might be a little bit more efficient than all that goofiness that we went to go stepping through a list and build another list that did not connect. Let's think of a better way to. So what do we do now? To extract the data that you need, replace all that list iteration code in your current program with 4 calls to sorted, set, so the set name, and then the slice thing, 0 to 3. So we don't have to worry about stepping through lists or creating a duplicate list. We'll just throw it in a set. That'll take care of all the duplicates going away, and then we'll just print out a sorted version of the set, and we'll just pull off the three top values. Give it a shot, see what it looks like. Alright, we've seen all this stuff before. That's our splitter function. Down here we're opening it up, we're pulling the first line out, we're stripping and splitting. So we get basically our list of garbage data. We're all cool with that. And then we come down here. Oh man, okay. So sanitize time for time in James. So we know about that. So basically we're taking the garbage list that we got directly from the coach, we're cleaning it up, changing all the dashes and the colons to be dots, 2.6 and stuff like that. Coming out of all that, we throw it into a set, because remember that's a list. We're going to throw it into a set, drop into a set. When we drop into a set, what's going to happen? All the duplicates are going to go away, right? Poof, because the set can't handle duplicates. And then we're going to sort the set. Cool. And we're going to print out square bracket, 0:3, square bracket. How many is that going to print out? First 3, right? And then we're going to put a print statement around the whole thing. It should work. Wow, that's a lot of code to collapse into one fairly hefty statement. Do you think it's going to work? Yeah. Do you? Really? All right. Here's our output. 201, 222, 234. Does it look like that's what we got last time? Yes. 239. Did that do it? So we took this much code, we made this much code, right? Is the code that we reduced it to still readable? Yeah. I mean, you gotta know what's going on, admittedly, right? But if you know what's going on, is it pretty clear? Yeah. Is it maybe more maintainable? I mean, it's 1 line versus like 25 lines, right? Alright, what's in your Python toolbox? All of this stuff. And we used a lot of it today too, didn't we? We used like sets, and we used lists, and we used ellipse.
And functions.
Oh, we did use functions.
We did.
Oh, and we used functions.
Yeah.
Man, you're just whipping those tools hard. Man, you're like building a house or something like that.
What do you mean by the toolbox?
Jeez, yeah, well, it's getting sort of worn, isn't it? All right, well, excellent, fantastic, well done. What did we do today? We talked about reading in data, we sorted it, we fixed the coach's mistakes, we transformed the list, We use list comprehension, and then we use sets to get rid of duplicates. Powerful, powerful things called sets. Whatever shall we do next time? We're going to do external libraries and a little bit more data wrangling. Fantastic. And, oh, I'm sorry, I can't remember. What's new to next class period?
Homework 4.
Homework number 4. And what should you do with your team before next class? You should at least assign roles.
Yes.
Maybe schedule meetings to sit down together and work through it all. Fantastic. Have a great time, and I will see you on Wednesday.